Okay, so divide using long division. Now the problem is going to look like this. So the direction is going to say divide probably. All right, direction says divide, and it'll probably say long division. Divide using long division. All right, now here's how it's going to look. So let's look at number one. So I'm going to write number one, and here's number one. We have m squared minus 7m minus 11 divided by m minus 8. Okay, now notice in the previous lesson, just to remind you, in the previous lesson, you had a polynomial divided by a monomial. See, that's one term. Whenever you have a polynomial divided by a monomial, that's where you break it into separate fractions. This first term divided by the denominator and so on. You only do that though if this is a monomial. This is not a monomial that's in the denominator. That's a binomial. So you have a polynomial being divided by another polynomial. Now I'm going to say this. Let me remind you. Y'all remember a monomial is a polynomial. So you do have, technically you do have a polynomial divided by a polynomial. It's just a monomial. Here you have two terms in the denominator. So you cannot use this approach. Here's how you're going to do this. Okay, you're going to use this using long division. Okay, long division. Now here are the steps. First thing you always have to do is make sure that both polynomials are written in descending order, and then filling in any missing terms with a zero term. Okay, so let's talk about number one. Okay, so this polynomial is in descending order, and so is this one. Descending order means you have your largest exponent first. See, that's a 2. Then this is a 1, m to the first, and then your constant is last. Okay, descending order. Here, m to the first, and then your constant. Your constant is last. There are no missing terms because my largest exponent is 2, right? So I see a 2, I see a 1, I see a constant. I'm good. I see a 1, I see a constant. I'm good. We're going to do one in a little while where there's a missing term. It's very easy to fix. Okay, so that's step number one. Step number two, divide the first term of the dividend by the first term of the divisor. And you're going to place the quotient above its like term. All right, now here's what that means. First of all, you're going to rewrite this. You're going to rewrite this using that long division format. So remember when you had something like 8 divided by 4? Now all of you know that 8 divided by 4 is 2. Let me do a different one. Let me say 9 divided by 4. All right, 9 divided by 4. You said this, right? 4 into 9. That's what you see here. See that symbol right here? Okay, and when you did this, you said 4 into 9 is 2. So your quotient here is 2. 2 times 4 is 8, and then you subtract it. Remember that? And so this right here became 2 and 1/4. So the remainder divided by the divisor. This is called the dividend. Let's just remind you, that's called the dividend, D-I-V-I-D-E-N-D. And the 4 is called the divisor, divisor. And remember the 2, this is called your divisor. The 2 is called your quotient. The 2, remember, is called the quotient. So just some things to remember from a long time ago when you divided numbers. Okay, so you got to rewrite this in this form now. So m minus 8, m squared minus 7m minus 11. So remember, the numerator is your dividend, the denominator is your divisor. So those are important to remember. The numerator is your dividend, the denominator is your divisor. Okay? So you're dividing this, the numerator, by the denominator. So you're dividing this by this. So you're dividing this into this. Okay? All right. Now, let's go back to that first step. Watch, it's very simple. Take the first term of the dividend and divide into the first term of the divisor. So m divide into m. So this divide into this. Okay? So if you have to write it down, you write it down. So here's what you're thinking. You're thinking this. You're thinking m squared divided by m. We just talked about those. What's m squared divided by m? Well, m squared divided by m is m, right? So this into this, first into first, okay? First into first. M squared divided by m is m. So divide, number 2, divide the first term of the dividend by the first term of the divisor. So m squared divided by m. M squared divided by m is m. Place that quotient above its like term. So I'm going to place this above its like term. So here's my m squared column, here's my m column, here's my constant column. So I'm put m above its like term. That's what that said. Okay. Now remember when we did this, the next thing, so when I said 4 into 9 is 2, what was the next thing we did? We took this multiplied by the divisor. 2 times 4 is 8. That's what we're going to do here. So look, m times the divisor. Okay, think about what you're doing. Most of you can do this in your head. So let me tell you what you're doing. You're saying m times m minus 8. That's what you're saying. M times m minus 8. Well, if you distribute, that becomes m squared minus 8m. That goes here. M squared minus 8m. Okay? Just like you did here. So let's kind of review. The first thing you're going to do is you're going to say m squared divided by m. So that's just right here, is m. Then, just like you did here, 2 times 4, you're going to do the same thing. M times m minus 8, though. And then write out if you have to. M times m minus 8 is m squared minus 8m. That goes here. Okay, so let's go through step 2. So step 2, remember, divide the first term of the dividend by the first term of the divisor. Okay, that was this right here. We get this. Put this here. Okay, step 3. Multiply that quotient from step 2 by the divisor. So that means this right here. M times this. That's step 3. So step 1, m squared divided by m. Okay. Step 2, multiply. So step 1, 4 divided by 9 is 2. Step 2, multiply. Okay. Same thing. All right. Now, here's where you have to be careful. So remember, once you multiplied, 2 times 4 is 8, the next thing you got to do is subtract. Remember that? You subtracted? So the next thing you're going to do here, and this is where you're going to be careful. See, most students don't have trouble here because those are numbers. Some students have trouble here because those are variable expressions. So here's what you got to think. You got to subtract, right? So you're going to say subtract, but put that in parentheses. Put that in parentheses because you're subtracting all of these terms. Now here's what I would do. There are a couple of ways you can think about this. So when I subtract this, what this means is you're taking the opposite. You're looking at the opposite. So the opposite of m squared is m squared. I'm sorry, negative m squared. The opposite of a negative 8m is a positive 8m. All right. Now here's what I would then do. Now we're going to add these two together. M squared and a negative m squared is 0. If, and you're going to see this as we go through all these problems, if you're doing this correctly as we go along, these will always cancel out. M squared minus m squared is going to be 0. A negative 7m and a positive 8m, negative 7m and a positive 8m is a positive m. And then we bring down the next term, minus 11. Okay? So it's kind of like if we had this. So for example, suppose I want to say 4 into, let's say, 93. All right? So 4 into 9 is 2. 2 times 9 is 8. Subtract. 9 subtract 8 is 1. Bring down the next term. That's what I did here. Bring down the next term. See that? That's what you're doing. Okay? Then you do the process all over again. So you see, remember that process? Step 1, m squared divided by m. That's your step 1 right here. Put the m here. Step 2, 2 times 4 is 8. M times m minus 8 is this. But then you got to subtract, right? So put that in parentheses and then rewrite it. Rewrite it. It helps to rewrite it. And then if you're doing this correctly, this should be m squared, this should be negative m squared, so those add up to be 0. A negative 7m and a positive 8m is m. And then you bring down the next term. Bring down the next term. Then you do the process all over again. So remember 4 into 13. So you're going to say m into m now. M into m. So that's going to be your next step. So let me go ahead and do that here. So then you're going to say m into m. M divided by m is 1. That goes, now that's a positive one, right? So that's going to go here. So you're going to say m plus 1, plus 1, positive 1, plus 1. And then you multiply 1 times m minus 8. I'm sorry, 1, excuse me. 1 times m minus 8. Well, 1 times m minus 8 is m minus 8, right? So that goes here, m minus 8. But remember guys, you subtract, right? So you're going to subtract, just like we did here. But rewrite it. The opposite of m is a negative m. The opposite of a negative 8 is a positive 8. Now let's see what we get. M and a negative m is 0. See how these cancel out? Every time we go through this process, process 1, process 2, process 3, and so on if we got to. But look, a negative 11 and a positive 8 is a negative 3. And you're done. Now here's why you're done. You're done because you see the first term here, that has a variable, right? M to the first. So that degree is 1, m to the first. The degree, you learned this in Monday's lesson. The degree of a constant is 0. The degree of a constant is 0. See, that's a constant. The degree of a constant is 0. 0 is less than 1. See, that's 1 right here. 0 is less than 1, so you're done. That's your remainder. That's the remainder. You can't go any further. All right. So the degrees of constant, now in the lessons you're going to learn on Monday and Tuesday, the degree is 0, and here's why the degree is 0. Okay, so listen carefully. I can rewrite negative 3 as negative 3x to the 0 power. So you see that 0 here? Because you know that x to the 0 is 1, so negative 3 times 1 is still negative 3. So you can always write a constant with a variable as long as you put 0 as the exponent of the variable. So the degree is 0. So you stop whenever the degree of the remainder, or this part here, is less than the degree of the divisor. Now here's how you write it. So remember how I wrote, let's go ahead and finish this one right here. 2 times 4 is 8. Okay, so 4 and 2, 13 is 3. 3 times 4 is 12. Subtract, you get 1. So you would rewrite this as the quotient, and so it's 23, and 1, the remainder, divided by your divisor. So the remainder divided by the divisor. So your answer is going to be the quotient, m plus 1, minus 3, the remainder, minus 3 divided by the divisor, m minus 8. So that's the answer. That's how you'd write the answer. So it's the quotient, and the remainder over the divisor. So that's how the numbers look that you did before, but these are variables. So you're going to write this as the quotient, m plus 1, minus 3 divided by the divisor. Okay? All right, so that's number 1. The more you do and you go through these steps, the easier it becomes. So let's look at another one. So this will be number 2. Number 2. All right, so let's suppose we had this in number 2. All right, so watch how simple this becomes with the more problems that you look at. Okay, so we have 2x squared minus 17x minus 38 divided by 2x plus 3. Okay, so remember this right here is written horizontally, so that means the same thing as this. 2x squared minus 17x minus 38 divided by 2x plus 3. So remember, that's not a monomial, so I have to use long division. And also notice, before you do long division, you got to rewrite this where both polynomials are in descending order, and any missing terms, you're going to put a 0 term. Notice there are no missing terms. X squared, x to the first, constant. X to the first, constant. No missing terms. We're going to do one in a little while where there's a missing term. So now you're going to write this in long division. So you're going to say 2x plus 3, and then 2x squared minus 17x minus 38. So remember, the numerator is your dividend. The denominator is your divisor. Now remember the steps. Step 1. Step 1. The first term of your divisor divided by the first term of your, the first term of your dividend divided by the first term of the divisor. So you're saying 2x squared divided by 2x. Well, 2 divided by 2 is 1, right? X squared divided by x is just x, so 1 times x is x. So that is x. Remember where you put it. You put the x under its like term. So I'm putting the x in this column. Then you multiply. Step 2, multiply. So you're saying x times 2x plus 3. Then distribute. Get rid of the parentheses. X times 2x is 2x squared. X times 3 is 3x. Put that underneath. Align your like terms. 2x squared plus 3x. Then remember, you got to remember, now you're going to subtract, right? So remembering what we did with numbers, with these. So you always subtract each, see, subtract, okay? But do it this way because you're subtracting variable expressions. Okay, now rewrite this without the parentheses. So the opposite of 2x squared is a negative 2x squared. The opposite of positive 3x is a negative 3x. All right, now, if you're doing this correctly, remember this is what's going to happen. These are going to end up being 0. See that? 2x squared and negative 2x squared, 0. That's always going to happen. So every time you repeat that process, you see how the first column always cancels out? All right, it's always going to look like that. A negative 17x and a negative 3x is a negative 20x. Bring on the next term. Now remember we talked about the degree? See, the degree here was 0, right? 0 is less than the degree here is 1. The degree here is 1. See x to the first? The degree here is still 1. Okay, so you stop whenever the degree here is less than this, but they're the same, so continue on. So you continue the process. All right, so this is the next process. So this is process 1, this is process 2. So that's this part here. Repeat. Okay, so repeat the process. Negative 20x divided by 2x. So this divided by this. First divided by first. First process, first divided by first. Second process, first divided by first. Well, that's going to be a negative 10. X divided by x is 1, right? So that's just negative 10. So that goes here. Then you multiply. See how it repeats? So then you multiply. It's going to say negative 10 times 2x plus 3. This times this. So this becomes negative 20x minus 30. So put that underneath. If you're doing this correctly, see how these are the same right here? These are the same, right? 2x squared, negative 20x. That's what needs to happen. So now if you subtract and rewrite this, the opposite of a negative 20x squared, negative 20x is a positive 20x. The opposite of a negative 30 is a positive 30. And then you get this, a negative 20x and a positive 20x is 0. Negative 38 and a positive 30 is a negative 8. And then we got to stop because the degree of a constant is 0. This degree here is 1. So the answer is the quotient, x minus 10 minus 8 divided by the divisor, 2x plus 3. Now be careful, it's only the remainder divided by the divisor, right? So just like we did this, the quotient, 23, and then the remainder divided by the divisor. So the remainder has to be divided by the divisor. The remainder has to be divided by the divisor, and that's what you see here. All right, so that's the answer. Let's look at another one. So this would be number 3. The more you do, the easier it becomes. It's just the same steps over and over again. Okay, number 3. So let's say we had this in number 3. We had k cubed minus 30k minus 18 minus 4k squared divided by 3 plus k. Okay, so remember Remember, it's got to be in descending order, right? This is not in descending order because you see the k squared's over here. So let's put this in descending order. So the largest exponent first. So that's k cubed, then the k squared, so minus 4k squared, then the k term, minus 30k, and then the constant. Now it's in descending order, and I don't have any missing terms. K cubed, k squared, k, and constant. So nothing was missing. We got to put this in descending order, so I got to put k first, so that'll be k plus 3. Okay, so now it's in descending order. So that's step 1. Remember, was to put in descending order, so that's what we did here. All right, now let's do the long division. K plus 3 divided into k cubed minus 4k squared minus 30k minus 18. And then all you're going to do is go through this process. All right, so let's do that. So remember step 1 is to take the first term of your dividend, k cubed, divided by the first term of your divisor, k. Well, k cubed divided by k, you know, is k squared. Put that over the k squared column. Put that here. So now you're going to take this. The next step is to take this, multiply by your divisor. So you're saying k squared times k plus 3, and then multiply. K squared times k is k cubed. K squared times 3 is 3k. Take that, put that here. K cubed plus 3k. K squared, sorry, 3k squared. If you're doing this correctly, remind you, if you're doing this correctly, these ought to be the same. Okay, remember that? See what happens? M squared, M squared, M, M. So that way when you subtract, they cancel out. So now, again, it helps to do this. You're going to subtract these now. Now get rid of the parentheses. The opposite of k cubed is a negative k cubed. The opposite of 3k squared is a negative 3k squared. Okay, now you're going to say this. K cubed and a negative k cubed is 0. A negative 4k squared and a negative 3k squared is a negative 7k squared. Now bring down the next term, minus 30k. Okay, remember each time you can bring down the next term. Okay, now you do the process all over again. So now the second repetition. First, second. Take the first term, negative 7k squared, divide by the first term, k. Well, that is just going to be negative 7, and the k squared divided by k is just k. So that goes here. So minus 7k. Now you're going to take this, multiply by this. So now you're going to take this right here, you multiply by your divisor. Okay? And then you distribute. So negative 7k times k is negative 7k squared. Negative 7k times 3 is a negative 21k. That goes here. If you're doing this correctly, remember these have to be the same. All right, so that way when you subtract, what's going to happen is the opposite of negative 7k squared is a positive 7k squared. The opposite of a negative 21k is a positive 21k. So that way now, what you notice is that these cancel out. Negative 7k squared and a positive 7k squared, those are opposites. You get 0. All right, let's look at this one. Negative 30k and a positive 21k is a negative 9k. Bring down the next term, which is minus 18. I can keep on going because you see this degree is 1, this degree is 1. So we do the repetition again. See, 1, 2, 3. So you take the first here, negative 9k, divide by the first, k. So notice every time I always divided by the first, right? Divide by k, divide by k, divide by k. This is just negative 9. K divided by k is 1. So I take this, put that here. See, it's under the constant column. Then we take this, multiply by the divisor. So notice the pattern. Every time you took this, multiply by the divisor. Took this, multiply by the divisor. Took this, multiply by the divisor. That was the pattern. So this becomes negative 9k minus 27. So that goes here. Negative 9k minus 27. Remember, if you're doing this correctly, those have to be the same, right? because now if you subtract, which is supposed to, the opposite of negative 9k is 9k. The opposite of negative 27 is a positive 27. So now when you combine like terms, these become 0. Negative 9k and 9k are opposites. Add them up, you get 0. Negative 18 and a positive 27 is a positive 9. And I cannot go any further because you're left with a constant. The degree of a constant is 0. The degree of my divisor is 1. So that's you're done. You just got to write the quotient. The quotient, so the answer is going to be the quotient, which is this, k squared minus 7k minus 9 plus, see that's plus here, 9 divided by the divisor, which is k plus 3. All right. So notice, oh, just want to remind you, see how I had a minus here? Because that was this. The remainder was a negative 3. Here, the remainder is a positive 9, so you say plus 9, just like that. All right. So that's your answer. Now, I know I'm running out of time, and I actually did run out of time, but I want to do one where the missing term is not there, so you know what to do. But it's in the lessons. If you go back to where those lessons were, you'll see some more examples there. But I just want to do one in the review. So this is going to be number 4. Let's go ahead and do this one. So this is going to be number 4. Let's say we had, okay, so let's do this. So let's say we had this. We had 42x squared minus 33 divided by 7x plus 7. I'm actually going to do one more, and if you have something to do, you can go on. I'm going to post this tomorrow, but I'm just going to do one more after this one, just to show you what to do if you get a remainder of 0. Okay, so let's look at this. So notice that y'all agreed that this is in descending order. Exponent 2 constant, exponent 1 constant. So it's in descending order. But the term's missing up here. Because see, there's no x term, right? There's no x term like you had here, m squared, and then you had an m term, m to the first power. You don't have that x to the first power here, so you got to rewrite it. So you're going to say 42x squared. Now here's how you put that missing term. Remember they called it that 0 term, the 0 term. So here's why they call it the 0 term. You're going to say 0 times x. 0 times x is 0. They call it a 0 term. So you have x squared, you have x to the first, and then minus 33 divided by, and there's no missing term here, so you're going to say 7x plus 7. All right. Now you do that long division. So 7x plus 7 divided into what you see here, 42x squared plus 0x. You got to have that missing term, minus 33. Now here's why you need that missing term. So you remember when we did that long division, you aligned your like terms. So the m squareds, the m's, the constants. So the exponent 2, the exponent 1, the constant. So you have to have that exponent 1 here. So you need that x column. So you have your x squared column, you have your x column, and you have your constant column. All right, so that's why you need, one of the reasons why you need that 0 term. Okay, so let's go through the process, and you can see how simple this is. So it's just the same thing over and over and over again. Okay, so 7. So you do first divided by 7x, right? So 42x squared divided by 7x. Well, 42 divided by 7 is 6. X squared divided by x is x. So put that here. See the why you need that 0 column so you can align your like terms. Remember, you multiply now, so you can say 6x times 7x plus 7. Multiply. 6x times 7 is 42x. 6x times, 42x squared, excuse me. And 6x times 7 is 42x. That goes here, 42x squared plus 42x. Now remember, if you're doing this correctly, those have to be the same, right? But now you're going to subtract, just like that. And when you subtract, rewrite it. The opposite of 42x squared is a negative 42x squared. The opposite of 42x is a negative 42x. And then you're going to combine like terms. 42x squared, negative 42x squared is 0. Remember that process? Let me find the one that was long. Remember this process? Cancel, cancel, cancel. Remember that? Always going to look like that. Now look, 0x and a negative 42x is a negative 42x, and then bring down the next term. We're almost done with this one, but that's all you had to do is this, and then you got the rest is the same as you've been doing. So now see what I'm doing? I'm kind of taking this little yellow paper to help me with the different processes. So we have first process and then the repetition. Negative 42x divided by 7x. See, remember, it's always divided by 7x, that first term. Negative 42 divided by 7 is a negative 6. X divided by x is x. That's your constant, goes above your constant term, minus 6. Then you multiply negative 6 times the divisor. Okay? Then get rid of that parentheses. You get negative 42x minus 42. That goes here. Negative 42x minus 42. Now remember, if you're doing this correctly, those have to be the same, right? But now you're going to subtract. And so the opposite of a negative 42x is a positive 42x. The opposite of a negative 42 is a positive 42. And then you combine like terms. These cancel out. That's what you needed. Negative 42x and 42x is 0. A negative 33 and a positive 42 is a positive, what's that, 9? Positive 9? Okay? All right. No, that's not positive 9. What is that? 42 minus 33 is 11 in it. So 11, is that correct? Okay, so 11. All right, so you're going to say 11 divided by, so let's see, that's going to be 6x. Oh, and then you stop there, right? You stop there because the degree here is 0, the degree here is 1. So the answer is going to be 6x minus 6 plus 11 divided by 7x plus 7. All right, so that's the answer there. Okay, so let's see. So this right here, I keep messing this up. This is a negative 33, right? And a positive 42. So that is 9. Excuse me. That is 9. Negative 43, negative 33, and a positive 42 is 9. Okay. All right, so that's number 4. I want to do one more just to show you something. One more, and then we're done. And if you got to go, you got to go, but I'm going to post this. All right, so notice every problem we've done had a remainder other than 0, right? So I want to show you what you're going to do, how you're going to write it if you get a remainder of 0. So let's do one where there's a remainder of 0. So let's look at this one real quick. All right, so let's look at this. You have 2x minus 1 divided into 4x cubed minus 6x squared plus 4x minus 1. All right, so there's no missing terms. We don't have to put any missing terms. It's already in descending order. Okay, so look. 4x cubed divided by 2x. Well, 4 divided by 2 is 2. X cubed divided by x is x squared. So put the 2x squared under the x above the x squared term. So 2x squared. Then you're going to multiply the quotient times the divisor. So 2x squared times 2x minus 1. Then distribute. That's 2x squared times 2x is 4x cubed. 2x squared times a negative 1 is a negative 2x squared. So that goes here. 4x cubed minus 2x squared. Now, notice that these are the same. That's what you wanted, right? But you got to subtract. And so when I subtract and get rid of the parentheses, the opposite of 4x cubed is a negative 4x cubed. The opposite of a negative 2x squared is a positive 2x squared. And then we're going to add. 4x cubed minus 4x cubed, 0. Negative 6x squared and a positive 2x squared is a negative 4x squared. Bring down the next term, plus 4x. Then, notice the yellow, you're going to do it all over again. So that you keep repeating. So you take the first divided by the first. So negative 4x squared divided by 2x. So notice always divide by 2x. Negative 4 divided by 2 is a negative 2. X squared divided by x is x. So negative 2x. So that goes in the x column. Minus 2x. So now you're going to take negative 2x, multiply by the divisor. So negative 2x times the divisor. And then you distribute. Negative 2x times 2x is a negative 4x squared. Negative 2x times a negative 1 is a positive 2x. That goes here. So negative 4x squared plus 2x. Remember, doing this correctly, those have to be the same. You see that? So that way, when you subtract, and you rewrite this, the opposite of negative 4x squared, that's an x, is a positive 4x squared. The uh, opposite of a positive 2x is a negative 2x. And now when I add them, look, negative 4x squared, positive 4x squared, 0. 4x and a negative 2x is 2x. Bring down the next term, negative 1. Keep on going because that degree is 1, that degree is 1. Okay, so the third process, look, the third process. 2x divided by 2x. Well, anything divided by itself is 1, right? So that's just 1. So I'm going to put a plus 1 here. 1 times 2x minus 1, the divisor, is just the divisor. So that's going to go here. But look, all these are the same, isn't it? So when you subtract, you get all of this. In fact, just look at this. 2x minus 1 subtract 2x minus 1. Y'all agree that's 0? But if you continue the process like we did here, the opposite of 2x is a negative 2x. The opposite of a negative 1 is a positive 1. And notice when you add them, 2x minus 2x is 0. A negative 1 and a positive 1 is 0. The remainder is 0. So what do you do with the remainder 0? Well, here's how you write it. Here's how you write it. It's just kind of, now look, it's just kind of if you had this. What is 8 divided by 4? Well, y'all agree that 4 into 8, you're going to say 2. 2 times 4 is 8. Remainder 0. Well, how'd you write that? You just wrote it as 2. You just wrote it as a quotient. The answer is just a quotient. Same thing here. So the remainder 0, you can say the answer is just the quotient. So it'll be 2x squared minus 2x plus 1. There's your answer. Since the remainder is 0, there's nothing else to put. You're not going to write it like this because here you had a remainder. So you had a remainder divided by the divisor. There's the remainder 0. So you're done. That's it. All right. So I know I went over quite a bit, but I just wanted to do as many of these as possible so that way you have the review and then you have some more problems that were done in the lesson. So that's dividing using long division. It does help though if you have this in front of you as you work through the worksheet on this. Okay? All right, so let me go ahead and turn this